formation, there are kinds of two things to think about. How do we form a bony skeleton? How do we start growing it in utero? And then how does it grow after you're born? What's postnatal bone growth like? So the formation of your skeleton begins in the 2nd month of development. Postnatal bone growth occurs until early adulthood when we fuse those epiphyseal plates. And then bone remodeling and repair occur across your whole life. And so this is a lifelong process that never stops. Bones, hopefully yesterday you all realized, bones are living organs. And sometimes you don't think about that. Bones seem dry and hard and like they're not doing anything. But they are. They're alive. They're living organs. They're our primary storage site for calcium. So if we ever need to get it out, this is where we're going to take it from. And so just kind of be aware of that. They're changing all throughout life. What's cool if you look at this is that we can see that our bony skeleton is formed from this cartilage mold in utero. But ossification centers, which is where we're going to overtake cartilage and replace it with bone tissue, start developing at 12 weeks gestation, so that you can see that even in utero we're starting to make bones. So up to about 8 weeks of gestation, fibrous membranes and hyaline cartilage molds are what we get, and then we start replacing it with bone. So there are two types of ossification. Ossification is how we're going to ossify what was cartilage. Ossification is the formation of bone tissue. So we can think of ossification as the formation of bone. So this is how bone is going to replace cartilage. And it's going to happen in two ways. The first way is called endochondral ossification. Endo means within, chondral is always referring to cartilage. So endochondral ossification begins with a hyaline cartilage mold. So we'll make a hyaline cartilage model of the bone, and then we'll overtake it and replace it with osseous tissue. So endochondral is within hyaline cartilage. And this is the one you're going to need to know a lot of details about. This is how most bones of your skeleton form. And so these would be our endochondral bones or cartilage bones, and this forms most of your skeleton. So this is the process. If I was going to ask you to describe or diagram or whatever on the test, this is the one I would want you to know. Intramembranous ossification isn't that complicated. It forms only not very many bones, like the bones of your skull and things. And if we think about this word, intra also means within, but now intramembranous. We're within a membrane. So as opposed to being like a hyaline cartilage well-formed mold, we're within a connective tissue membrane. And if you remember, all of our connective tissues are starting with that mesenchymal tissue. So we can have this mesenchymal membrane form, and then it's going to slowly be overtaken by bone through intramembranous ossification. And so we'll talk about that a little bit, but we're not going to go over the nitty-gritty details. So we'll just say this happens within a mesenchyme membrane, or a mesenchymal membrane. So this is how we form our flat bones of our skull, things like that. So, endochondral ossification is the one that we'll talk about in great detail. And your book breaks it down into a 5-step process. So, we'll do that. We look at first what happens that we have this hyaline cartilage mold formed. And remember, hyaline cartilage is just one step away from mesenchyme as well. I mean, maybe not. I don't know exactly how many differentiating steps mesenchymal cells go to become chondroblasts. But so they're still not far away, and we're all sharing the same stem cell tissues to begin with. So I have this hyaline cartilage mold, and then I'll start seeing this development of what we call the bone collar around that hyaline cartilage model. And so some of those cells are going to differentiate and become those osteoprogenitor cells, and this is going to ultimately form our periosteum. So So for our first step of endochondral ossification, what we could say is that a bone collar forms around the hyaline cartilage mold. So our bone collar forms around the mold. And then what we'll see is that some of those cells in the center are going to form what we call a primary ossification center. And this is going to be where we start ossifying this tissue. So the other thing we could say for step one is that a primary ossification center develops in what's going to be the diaphysis. So our primary ossification center develops in the diaphysis. So a bone collar forms around the outside, and a primary ossification center forms on the inside. Okay, so in this ossification center, what's going to happen is we're going to start accumulating lots of calcium and calcifying. As that happens, it's going to kill off chondrocytes, and the medullary cavity is going to start hollowing out and lengthening. So for our second step, we could say that calcification of cartilage in the primary ossification center kills off our chondrocytes and begins hollowing out the medullary cavity. Okay, so for our second step, we'll start accumulating high amounts of calcium. Chondrocytes don't like to live in hypercalcemic environments, so they'll die off, and we'll start hollowing out that medullary cavity. I'm not doing anything with the lower part. Is everybody good on stage one? Shout no if no on one. Okay. So for our third step, what we'll see is the invasion of what we call a periosteal bud. A periosteal bud has branches of the vessels and nerves that are going to serve that bone. So it's going to invade the growing diaphysis and start branching. Our blood vessels and nerves are going to start branching up and down it. We have an actual bone collar forming out here on the outside of the bone. So when my periosteal bud invades, it's going through that bone, creating a foramen, and bringing with it into the inside of the bone all of our bone cells. Because all that happened on the inside of the bone is I calcified cartilage. So if I just have dead cartilage, that doesn't magically become bone unless I introduce bone cells. So what we could say for our third step is that the periosteal bud invades, bringing with it all blood cell types. Periosteal bud invades, bringing bone cells with it. And then if we want to know what a periosteal bud is, it's just this group of organs that are coming in to serve the bone. It contains the blood vessels, lymphatics, and nerves that serve the bone.
What does this have to blood vessels?
Lymphatics. So now that we bring in this bone, we can start replacing those spaces and filling it with bone tissue. So we would start to see spongy bone forming in that primary ossification center. So when we bring with it our bone cells, what we can say is that spongy bone forms in the diaphysis. So for our third step, our periosteal bud invades, bringing with it all bone cells. So now we have these nice hollowed out spaces from where our chondrocytes died off, and we can overtake that space and fill it with spongy bone on the inside of the medullary cavity. Then as development continues, what we'll see is that this diaphysis is going to begin ossifying. We'll be laying down compact bone on the outside, and we'll look at how all of this growth is happening both interstitially and appositionally in a minute. But we'll be ossifying this growing diaphysis, and we'll start to see the development of what are called secondary ossification centers in our epiphyses. And so in each of those now, we will also see that we're bringing in blood vessels to serve these bones as well. And now when we have red marrow in there, well, and all throughout here, we can get all of our new blood cells being made and right easily into our blood vessel system. So for this fourth step, we could say that the diaphysis is going to elongate, and with it so is the medullary cavity. And then we'll see the development of secondary ossification centers in the epiphyses. So the diaphysis elongates, our medullary cavity does too. And we see secondary ossification centers develop in our epiphyses. So, how many secondary ossification centers do I get then? 2, because there's a proximal and a distal epiphysis. So our secondary ossification centers develop in our epiphyses. So now what we're going to do is we'll continue ossifying this growing diaphysis, but we're going to begin also ossifying our epiphyses. I'm not ossifying it all at the same time. What's going to happen then throughout the rest of childhood and adolescence after this kind of phase is that the only cartilage that remains is everything here at the epiphyseal plate. And that will be overtaken by bone throughout adolescence as you grow. So kind of where we can leave it for stage 5 is what happens from birth through adolescence is what's happening here. So we could say for our 5th step that our diaphyses and epiphyses are going to both continue to ossify, and the only cartilage that remains is at the epiphyseal plate, and on the ends of our bones is articular cartilage. So for our last step, we'll say our epiphyses ossify. The diaphysis has been ossifying all along, so what we can say here is that the only cartilage that remains is at the epiphyseal plate and is articular cartilage. So we started with this hyaline cartilage mold, and we put some bone around it, and then we started killing off the cartilage, and we brought some bone cells into it. And so we start ossifying here. We get our secondary ossification centers here. So we ossify here and here. We're ossifying here all along, so that all throughout childhood and adolescence, the only place I have hyaline cartilage remaining is at the epiphyseal plate, and that's going to be where postnatal bone growth occurs. So we'll talk about that in a second.